This is part 4 of section 3.5, our last problem. This particular problem has a slant asymptote, and we're going to use it and the 7-step strategy to find the rational function. Okay, I know I have a slant asymptote because the degree in the top is greater than the degree at the bottom. Okay, so what you're going to do to find a slant asymptote is you're going to do a division. Now you can do this as a long division, you can use synthetic division, you can sometimes split it up into multiple fractions and reduce it, but whatever it is, you need to get it divided. So one method here would be, because I have a monomial on the bottom, I could write this as x squared over x minus 4 over x, which simplifies to x minus 4 over x. Okay, I also could have done a long division. And I would have ended up with the same thing. Okay, so I get this. I will use this in a minute to find the vertical asymptote, but that's what I've the slant asymptote. Sorry. Let's go through now and go through our steps. This doesn't really reduce. I mean, it didn't reduce nicely, beautifully. We did the division, but it didn't come out to something nice. I still had a remainder here. Let's find f, so I'm going to use our original. So I'm going to find f of negative x, and that will give me negative x squared minus 4 over negative x, which is x squared minus 4 over negative x. Now this is not exactly the same as this, so it's not an even function, it doesn't have y-axis symmetry. However, remember we can have a negative in the top and the bottom and off to the side, and it's all the same thing. So take that negative out of the bottom. And now we look without the negative and compare it to our original, and we have the same thing. This is an odd function, which means we have symmetry about the origin. And so what that means is whatever I have drawn in this quadrant, basically you can imagine flipping it down and then flipping it over, and it would be mirrored right here. So this one mirrors this one mirrors this one, which is, symmetry is great. It makes graphing very easy. As soon as you find one point, you found another. It's really quite nice. All right, step 2 is to find a y-intercept, if we have one, by finding f of 0. But what happens when I plug in 0? I get 0 on the denominator here. That can't happen. There's no y-intercept. Okay, because that was undefined when I plugged in 0. All right, part 3 is to find our x-intercepts if we have any, which means you take your numerator and set it equal to 0 and solve it. So x squared minus 4 equals 0. Well, that's x squared equals 4. Take the square root of both sides with a plus or minus, and you get x equal plus or minus 2. So I have an x-intercept at negative 2, and I have one at 2, 0. And remember, I have symmetry, so I kind of expect this to happen. So I'm going to go ahead and plot these. 2, 2, 0, and negative 2, 0. Okay. Step 4 is to find vertical asymptotes, which means we looked at this after we reduced it and it doesn't reduce. What makes your denominator 0? X equals 0. Okay. This is our vertical asymptote, and that is our y-axis. And we did not have a y-intercept, so that makes sense. Now, we don't have any holes because nothing reduced away. So I just have a vertical asymptote and no holes. Okay, now step 5. This was a horizontal asymptote. We know we don't have horizontal asymptote, but we do have a slant asymptote. Now, how do we do this? Okay, come back up here, and where we did our division, Your slant asymptote is going to be y equal this, except you take away the remainder. Okay? Now, why is that? It's because by an asymptote, we're wanting to know what happens when x gets really, really, really big. So when it goes to infinity or when it goes to negative infinity. We want to know where this thing trends. If this denominator gets bigger and bigger and bigger and bigger, then this fraction is getting smaller and smaller and smaller and smaller until it's practically zero. And since we're wanting to know what happens when x gets really, really, really big, or, negative infinity, really large negative numbers would do essentially the same thing. This would become essentially zero. So as x gets really large, it's pretty much the same thing as x. Okay, so we have a line that's going to work as an asymptote. It's the same basic idea. We're going to get really, really close to this, but we probably aren't going to touch it. We need to find out if we cross it. Okay, so I'm going to take this, our original, and set it equal to x. And if we get an answer somewhere, then that means we do cross it. So I take x squared minus 4 over x, set that equal to x. I would multiply both sides by x. I get x squared minus 4 equals x squared. And then again, you get something ridiculous. Negative 4 equals 0. So we never cross this. Okay, so let's figure out what we have. So far we have 2 points. All right, so I know I have odd symmetry, which is going to be really helpful here. I don't have a y-intercept. I've plotted my two x-intercepts. I have a vertical asymptote that is the y-axis. So I know that on either side of this, my graph is either going to positive infinity or negative infinity. Okay? And now I need to graph our slant asymptote. This is the identity function. And it is the straight line, the diagonal line that cuts these two quadrants in half. Now, since it's an asymptote, I'm going to put it in with a dotted line. If I can line things up correctly. Here, that's pretty good. Okay, so what do I know? My graph might be up here. It might be here. It is going to be here, definitely because of that. And here. Or it could be here. I mean, I'm assuming I don't know these 2 points. But I know that this is going to graph it. It's going to attract the graph towards it. Now we need to plug in some points. And although we have a pretty good idea, because I know I never cross this and I never cross this, my graph has to hug to go through these points. Okay, it's got to do something like this. Okay, and then here. There's no other way to get it done. But I could plug in other points. Let's say I plug in 1. So this is like step 6, and I'm kind of verifying what I have here. If I plug in 1, what do I get? I get 1 minus 4, which is negative 3, over 1, negative 3. Well, at 1, my graph did end up going through negative 3. And since I have symmetry, if this is negative 3 and I plugged in 1, then what that automatically tells me is if I plug in negative 1, I should get positive 3. 1, 3. So I have another point. You can keep doing this. If I plug in, I did. If I plugged in 2 and negative 2, I got zeros. But if I plugged in 3 and negative 3, they should just have opposite answers. So this would be 9 minus 4, which is 5, over 3. So I get 5/3. And then for this one, I would get negative 5/3. And that's 1 2/3, right? So at 3, 1 2/3 seems reasonable. At negative 3, negative 1 2/3 makes sense too. Okay, so a slant asymptote works essentially the same way as a horizontal asymptote. You're going to be attracted to that. You're going to be getting really close to it. Most of the time you don't cross it, but it is possible.